Okay, so in the last video we introduced and talked a little bit about the integral test. Okay, now we're ready to use the integral test. Talk about using it to check whether or not something converges or diverges. Okay, so first things first, if you were checking this with the divergence test would be inconclusive, right? Since it's k over k squared plus 1, as we go to infinity, this would be the same as k over k squared, which would be 1 over k, which would go to 0, so the divergence test is inconclusive. Okay, so now we're going to turn to the integral test. So we're looking at this thing by comparing it to the integral from 1 to infinity of x over x squared plus 1. So we need to work out this integral. Okay, so remember, this is limit as b goes to infinity of the integral from 1 to b. All right, so what are we going to do with this thing? Well, we have x over x squared plus 1. We want to work that integral out. So we can let u be the bottom. So 1 over x squared plus 1. And that would call for us to have a 2x left over to go with our dx. We already have the x. We are missing a 2, so we would need to put a 1/2 out front. So now I have 1 over u, right? 1 over u, and then du. So remember, integral of 1 over u is just natural log. So this would be limit as b goes to infinity of 1/2 times the ln of the absolute value of x squared plus 1. Right, and that's going to be evaluated between 1 and b. Okay. So simplifying, we would have limit as b goes to infinity of 1/2 ELN. Absolute value doesn't really matter here because this stuff's positive. B is going to infinity. So that would just be the same as b squared plus 1 minus 1/2 ln of 1 squared plus 1, which would be 2. So what's going to happen? Well, ln of 2 is just a number times 1/2. It's just a number. But as b goes to infinity, ln also goes to infinity. So this is equal to infinity. So therefore, the integral diverges, and so does the series. So does the series. So that infinite series of k over k squared plus 1 is going to diverge. K over k squared plus 1 is going to diverge.